Scientists pioneering a new era. Kyoto University, Mr. Shun Kiyose. Manufacturing technology for miniaturized atomic clocks for beyond 5G society. The beyond 5G society requires real-time data processing between edge devices. The key is a small atomic clock chip. Conventional quartz clocks use the vibration of a quartz crystal with an error of, say, 1 second every day to 10 days. The atomic clock uses the frequencies inherent in cesium atoms to perform quantum mechanical measurements and realizes an extremely high precision accuracy of 1 second in 1,000 years. We have studied the microfabrication technology of vapor cells, which is the key component of atomic clock chips. Currently, atomic clock chips are about the size of a matchbox and cost several thousands of dollars each. So they need to be smaller and of lower cost to install them in consumer products for a beyond 5G society. We developed a manufacturing technology for vapor cells, in which cesium gas is sealed in a container of only a few millimeters. Our technology will enable miniaturization and cost reduction of atomic clock chips. We fabricate pillars with multiple reentrant structures the thickness of a human hair by microfabricating semiconductors. We can realize highly efficient vapor cell manufacturing at the level of semiconductor wafers such as CDs. We use conventional semiconductor production equipment to reduce the initial cost of manufacturing. Atomic clock chips can be integrated into edge devices around the world to enable sophisticated and precise control. This will create new applications, such as advanced self-driving vehicles, smart drones, and avatar robotics to create a beyond 5G society. Manufacturing technology for miniaturized atomic clocks for beyond 5G society.